What's up, math scholars? It's Monday morning and everybody's bright and cheery and awake. And it's really, really, really cold outside. Were you guys cold standing out for the bus? Or you all drive? You're still pretty young. You might be running a bus. But yeah, we're reviewing for a quiz this week, so that should be fun. 2 days of review. We have a quiz Polaris portion on Wednesday and paper portion on Thursday. So who's excited that you have a 5-day weekend coming up? Woo, 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 woo! Yeah! We are so excited. Okay. Number 1, you can either cross cancel things early on or leave the canceling until the very end. I kind of did a mixture of the two when I did this one this morning because I didn't feel like figuring out what 21 times 3 is. Not that that's a huge number, but I didn't feel like doing it. So what I did is I did 3 divided by 3 equals 1, 6 divided by 3 equals 2. I did 15 divided by 3 equals 5, and I did 21 divided by 3 was 7. And that just made my numbers a little more manageable. I did decide to simplify all my variables at the very end. So multiply straight across the top. It'd be 7 x to the 25th, because even though we're multiplying, we add those variables, add the powers. Y to the 23rd. On the bottom, we have 10 x to the 3rd, y to the 9th. So we have just a little bit more work to do. We have to simplify down our x's and y's. How'd the song go? Oh my gosh, they know the song so well. That'll help on your ACT. Bigger. Hey, who took the ACT on the weekend? How was it?
It's pretty hard.
Did you have to sing any of the math songs? Like bigger, minus, smaller?
Yeah.
You did? That makes me so proud. Yeah, it's pretty hard. Did you think the reading was the hardest?
Yeah, it's pretty hard.
One of my students said the reading was like just too long, you know? You have to go really fast in reading. What? What'd you say? Not enough time?
Yeah.
Yeah, not enough time for reading. Holden, hi! Check your happy news in chat. Oh gosh, we're still rolling the video. Bigger minus smaller, put the answer where the bigger lives is 22. And then bigger minus smaller, put the answer where the bigger lives is, what is 23 minus 9? 14?
Yeah.
Okay, had a brain freeze. So we have to do division of fractions. So I guess the good news is we do not need common denominators. So what do we need to do? Logan? Yeah, we're going to make it a multiplication problem. We're going to flip this one upside down. But it looks like we have a big old bunch of factoring, a whole bunch of factoring to do. I'm going to factor this bottom part into x plus 4, x minus 2. I'm going to factor, this guy would end up being on top. He'd be x plus 4, x minus 4. And then this guy would be on bottom. He's going to be x minus 4, x plus 3. Make sure I'm not making any mistakes here. It's early. I saved that top left into last because it looks like the box method. Dun, dun, dun. You already did it. Good, so Jake can help me. What's going to go in my upper left box? What's going to go in my lower right box?
3.
And then I do what?
Multiplying. Yeah, sure, but the answer equals
6. Okay, so
then you get a 1 x and a 6x.
1 and 6 is what we're going with. I'll pull a x out of here, making this a 2x and a 1 and a 3. Does that look like about what you got?
Yep.
So we'll have a 2x plus 1 with an x plus 3. And then this is my favorite step. You can cancel all your factors up that line up diagonally and up and down. Holden's happy news is he got some sleep over the weekend. That's good. Got diagonal, and we got up and down, and there's not much left. A 2x plus 1 over an x minus 2. All right, how do we find LCMs? What will I do first? I need to compile my checkmark list. But before I do checkmark, put them on my list, I have to, Alana? Factor each one. Yep. So I think we can do common monomial in the first one. Pull out a common 5x, leaving you with x plus 2. And we can do old-fashioned factoring in the second one. X plus 2, x plus 1. All right, my favorite is doing my checkmark list. I checkmark my 5. I put them on my list. I checkmark my x. I put them on my list. I check mark both my x plus 2s. I put them on my list. This is a big common least common multiple, and then x plus 1. So it's called a least common multiple. I also call them least common denominator. That's what it would look like. All right, we're transitioning to adding fractions. What do we know about adding fractions? Evan?
You need the same denominator?
We need the same denominator, and we call it the LCM or the LCD. It's really the same thing. If this is my denominator and this is my denominator, I would check mark both of them and get them on my list. So x minus 3, x plus 5 is going to be the common denominator that we're using on this problem. So we need both of our denominators to look like my LCM. X minus 3, x plus 5. X minus 3, x plus 5. So my original denominator here only had an x plus 3. I'm going to need to multiply by x plus 5 to get them to match. The 7 will distribute, so it'll be a 7x plus 35. So we good so far? All right, this one over here, we've got these x plus 5, so I'm going to need to multiply by an x minus 3 to make those denominators match. And then I distribute 3x minus 9. It's still looking good. When I add straight across the top, I'll have 10x, and then what's 35 minus 9? 26. And in my denominator, x minus 3, x plus 5. So there's your answer. Alrighty, number 4, solve the equation, check for extraneous. What's our strategy going to be? I honestly think the hardest part of these is figuring out what your strategy is, what you're going to do when. What are we going to do, Jake?
Cross multiply?
Yep, it's just a proportion. When you see that equal sign in the middle, it means you don't need to worry about common denominators or anything like that. It's just cross multiplying. So this cross product is going to equal this cross product. So I'm going to have a FOIL party over here on the left. X squared plus 2x minus 3x minus 6. I'm going to distribute on my right, x squared plus 5x. And then when I get everything on one side, it doesn't matter if you get everything on the left or the right, because your x squareds are going to go away. So once you discover that, you're just solving a linear equation. This ends up being a negative 1x minus 6 equals 5x. So I'd probably just get my x's on the right and my numbers on the left and divide it out to finish. You don't need to use factoring to finish because it's a linear. Divide both sides by 6, negative 1. Now this is definitely 1, but I look back at the top and I make sure I can put a negative 1 in both denominators, and that it would never cause me to divide by 0. So like if I got negative 5 as an answer, that'd be a bad answer. If I got negative 2 as an answer, that'd be a bad answer. But negative 1's fine. What is our strategy going to be on number 5? Jake?
Same thing.
Same exact thing, I know. These are easy ones. So we're going to do our cross product, 9 times x plus 2. Do our cross product, 3x times 4. So it'll be 9x plus 18 equals 12x. It's a linear again, so I don't need factoring in anything fancy. I can just solve it like an Algebra 1 student. Looks like we're going to divide both sides by 3 and get 6. Does that look like an answer you guys got? And that is not extraneous, because I could put a 6 in either place for x in those denominators and not get 0. All right, I kind of wanted you guys to work in a group and talk, but you're working but not talking. I think the hardest part on 6, we were chatting in my first period, is literally just figuring out what to do. They kind of tell you in the instructions to use the LCD, but how are you going to use the LCD? Are you going to make all the denominators matched, or are you going to try to clear all the denominators out? What's the strategy, Jake?
Clear them down.
Yes, so number 6, maybe make a note to yourself. On these, you want to clear the fractions out. So you want to multiply through by the LCD, but clear all the fractions. The strategy is make the fractions go away. So do you guys know what your LCM was, or your LCD that you're going to be clearing, or you're going to be multiplying through by to clear? X minus 2, x plus 2. Okay, so I will multiply every single term by that, and all the fractions will go away. So when I put my x minus 2 x plus 2 here, the x minus 2's go away. So I'm just left with an x plus 2. When I put it here, I don't have a ton of space, but it's just going to become a foiling party. Not a total terrible thing, but a little bit of work. So I'll do the foiling down here where I have more space. And then this one, when I put my x plus 2, x minus 2 here, the x plus 2's go away. And I just have to distribute my 3x. So 3x squared minus 6x. So now it's going to be a piece of cake. I'm going to do a little bit of foiling. I'll get everybody onto one side and hopefully not have to use the box method. That's everybody's wish. So it'll be x plus 2. This will go to there. 2x plus 4. And it will foil with this x minus 2. Let's do our FOIL party. That's going to be 2x squared. That's a negative 4x. That's a positive 4x. They go away, which is awesome. It's because these two are conjugates. And then that's going to be a negative 8. So does this end up being box method or not? Nope. Which is awesome. So when I subtract my 2x squared over here, I just get an x squared. When I subtract this x over to here, I get negative 7x. And then when I add these two numbers up, I have a negative 6, so I add it to the other side. That's where we're at right now. Beware of the double negative. It's negative 6 and negative 1. So 6 and 1. What? Do both of those answers work? I've come to almost expect an extraneous. Do they both work in the original? You look at your original denominators, and you make sure they can go in for x without making the denominator 0. So they both work. 6 and 1. They both are good solutions. Real similar. Our goal is still going to be to clear those fractions out. What did you guys come up with for your LCM to multiply through by? Evan?
X minus 4.
Yeah, an x with an x minus 4. So when I put, still have a lot of workspace up here. My equation typer doesn't allow me to put workspace in, leave a bunch of blanks. So it's x with an x minus 4. That's going to cancel the x and leave me with 10x minus 40. When I put the x in the x minus 4 here, it's going to give me 3x squared minus 12x. And then when I put my x times x minus 4 here, the x will distribute in, so x squared plus 9x. Ooh, does this one end up being box method? Kind of looks like it might. I'm going to get everything over on the right. When I subtract this x squared over to here, it'd be 2x squared. I've got a 10 and a negative 12, so together that'd be a negative 2x. And when I subtract a 9 over to join a negative 2x, it'd be negative 11x. And then we've got the negative 40. Yep. Box method time, my favorite. Actually, it's not my favorite, but it's fine. I like grouping the best. So the 2x squared in the upper left, negative 40 in the lower right, and that would give you a negative 80. I think we might have saw this one in class last week. Do you remember what multiplies to negative 80 and adds a negative 11? Logan?
16 and 5.
Yep. We'll make the 16 our negative, the 5 our positive. Do you remember doing this one in class? Maybe it was a different class then. I just remember the 16 and 5. I'll pull a 2x out front here, an x and a negative 8 over here, and a 5 here. That works. So our answers are 8 or negative 5 halves. And they both work if you look at the original problem. Last one on the big sheet of paper. This is called a complex fraction. What was our game plan when it came to complex fractions? Evan?
Make the denominators the same, then they cancel out.
Yeah, so basically come up with what the common denominator is. Multiply through. So it's a fraction clearing technique. So fraction, I'll write that our strategy is fraction clearing. Fraction clearing technique, multiplying through by the LCM. So what is the LCM I want to multiply through by? Anybody know? So the denominators I'm looking at is the x plus 2's and the x's. So if I do the check mark list, I'll have the x on my list, and I'll have the x plus 2 on my list. So my LCM is x times x plus 2. I will multiply every single term by it, and all these in tiny denominators will go away. Now the whole entire fraction won't go away, but the little 3 denominators will. So if I multiply by x times x plus 2 here, the x plus 2's go away, it's just a 3x. If I multiply by x times x plus 2 here, the x's go away, and it's just a 5x plus 10. You'll distribute your 5. And if I multiply by an x and an x plus 2 here, it'll just be an x. So our final answer is 8x plus 10 over x. And remember the day Evan's like, can I cancel these x's out? Only if you want to go to math jail. So you want to leave it like this. I think number 9 is going to be the hardest one we do today because the LCM is humongous. It's a subtracting fraction problem, so we need to get that common denominator. We need to make the denominators match. But it also has the added bonus of being a subtraction problem. And my official advice on subtraction problems is make them addition problems. So make this an addition problem, and make the 5x a negative 5x. And it'll just make your life easier. Okay, so let's factor the bottom so we can kind of figure out what our common denominator is going to be. This bottom would factor into x plus 3, x plus 1. The lower right denominator would factor into x plus 3, x minus 3. My numerators are still just hanging out. So, let's talk about what our LCM is. Anybody know? It's kind of big. Jake?
X plus 3, x plus 1, and x minus 3.
Yeah, isn't that's kind of like the biggest common denominator we've ever used, isn't it? Yikes. Blah. All right, so I want both my denominators to look like what Jake just told me. X plus 3, x plus 1, x minus 3. X plus 3, x minus 1, x minus 3. All right, we have a little bit of work to do because none of my denominators have the common denominator that we need. I've got my x plus 3, my x plus 1 up here, but I don't have an x minus 3. So that's what I'm going to need to multiply by. I can do a quick FOIL up here. X squared minus x minus 6. Over on the right, looks like I have everything I need except that x minus 1. So I'll put my x minus 1 here and here. It'll give me a negative 5x squared plus 5x. I think, how are we looking so far? Did I mess up? X plus 1. Ah, rates. So here I had it wrong, and here I had it wrong, and then here I had it wrong. Thank you. You literally just saved the day. Guess what you get?
Like you almost went into math jail yourself.
I am in math jail. Lauren just bailed me out, so she's getting a homework pass. How's that looking, Lauren? Am I better now? Yeah. Whenever I like do something, I say, how are we looking? And I turn around, somebody smart has their hand in the air. I'm like, crap. Where did I mess up? I know pattern. How that happened. I'm in math jail. There you go. Thank you. Okay, are we looking good now? In my numerator, I'm ready to plow across the top, adding the numerators. So in the numerator, I would have negative 4x squared, negative 6x, and negative 6. We tried common monomial factoring this last period. We even tried box method, but it wouldn't allow us to cancel anything out with the bottom, so just leave it. On the bottom, x plus 3, x plus 1, x minus 3. Whew, that was a lot. All right, last one. I need ideas from the class what our strategy is going to be. This looks like a doozy. Jake, what do you think our strategy is going to be?
Find the least common denominators and factor it out.
So, you still didn't say the key phrase, though, that I was looking for. Clear the fractions. Our strategy is going to be clear the fractions. by multiplying through by the common denominator, okay? Before I find the common denominator, though, I'm going to do a couple things. I'm going to make this an addition sign, and I'm going to make this a -2. It'll just kind of help with our math. And then I'm also going to factor this denominator here into 2 times x plus 4. So I think that will help us on our journey to figuring out what our LCM is. I'm going to actually write my LCM up here so it's not in my way. What is our LCM? James, you've been so quiet today. What's our LCM? 2 with an x plus 4, like that?
Yeah.
Yes, I agree. 2 with an x plus 4. So everyone's going to get multiplied through by the 2 and the x plus 4. So I'll put the 2 here. I'll put the x plus 4 here. The x plus 4s go away. Now this is a little confusing. What you're left with is a 4 with an x plus 7. So the 4 will distribute to the x plus 7. The 4 comes from the 2 times the 2. You see that? Kind of weird. Okay, this term here is going to get multiplied by the 2 and the x plus 4. So what ends up happening is the -2 and the +2 multiply, making it a -4. And then the -4 will distribute to the x plus 4. You can do it like that if you want. And then over here, if I multiply by 2 and an x plus 4, you know what will happen, right? The whole entire denominator will cancel, so it's just the 2x plus 20. This will not be bad to finish. There's no x squared. It's just a linear equation. Okay. So we'll have, oh no, did I mess something up? All my x's are about to disappear. Lauren, did I mess anything up? So it's going to be 4x plus 28. This is why I said, oh no, this is a -4x minus 16. All my x's go away on my right-hand side. Did I mess up?
Not all of them.
Well, I mean these two. These two a little though. So it's just awkward when that happens. This is going to be, what, 12? Bring your 20 over, so it's -8. And divide by 2, -4. Uh-oh. Uh-oh. That's extraneous. We trashed the answer. There's no solution. I actually did look up the answer in the book to check myself because it was like 7:30 when I was doing this, and it is a no solution problem. I pulled most of these problems just out of the textbook. So if you're looking for extra practice problems, you can always pull the textbook. Or I could share it with you. Share the chapter. Oh gosh, are we done? Awesome. We have to say goodbye to all of our subscribers, all our math scholars on YouTube. Hope you guys have a fabulous day and you go outside and do some sled riding tonight after school. Who's going to go sled riding after school today? My son wants to go, so I probably will. Have a good one. Bye. Audio.